Alright. Alright, so an equation equals is an problem with an equal sign. Okay, we have a couple of key words that mean equal. So equal can be is, okay, equals, which obviously is the same. Okay, anytime we see those two things, it's going to mean that there's an equal sign there. Okay, it can also mean the same as, which is also right here in your notes. Anytime you see that, that means equal. So we're going to take these step by step and we're going to chop them up into pieces and kind of code them so that you get used to the process of coding them, because I feel like part of our issue with chapter 7 was not knowing some of our key words. Okay, so we're going to hopefully do better with that this go around. So in example 1, they show us how to chop it up. Okay, it says the sum of a number n and 7 is 15. They've highlighted the word is, and is means equals. And then everything before it they've highlighted, and that's the problem part. And then after the is the answer part. Okay, so I want you to kind of look at that and see how they did that. We're going to practice doing this together. Okay, so the sum of a number n and 7 is 15. Well, sum means to what? Add. So we're adding n and 7, which equals 15. In example B, we have a number y decreased by 4 is 3. So we have our keyword is, and then we have a number decreased by 4. Well, what does decreased by represent? What? Subtraction. So we have y minus 4 equals 3. Okay, so we're going to practice some of this under that try it part. So one color is going to represent your equals mark, and the other color is going to represent your problem part. Okay, so I want you to get your one that's going to represent the equals part. Okay, number 1 says 9 less than a number b equals 2. Well, what keyword in here means equals? Equals. So I want you to highlight that with one color. Then I want you to take your other color and highlight the problem part. Okay? You're going to pick up your pencil. Okay, equals, we're literally going to draw the equal sign under it. Equals 2. And I know you're thinking, oh my gosh, this is so silly. But promise me, when you work through decoding these, it'll get better. Alright, we have 9 less than a number b.
So 9.
So less, what is our key word here?
Less than.
Less than. Okay? But less than is special. Less means to subtract, and than means to swap. I want you to write that so that you get the habit. We're going to decode this.
Do we write this with a pencil?
I would write this with a pencil. Alright, now when we swap, we're not swapping everything. We're only swapping the problem part. Okay? So when we swap, we're only swapping what's happening in what's mine is blue. We're swapping the 9 and the b. Okay? So how could I write this?
B minus 9 equals 2.
B minus 9 equals 2. All right, get your equals highlighter. Number 2 says the product of a number G and 5 is 30.
Is.
What's our keyword here?
Is.
Is. So there's my equal word. Get your problem highlighter. Which one's the problem? The product of a number G and 5. Alright, now we're going to code it. I'm going to go ahead and put down my equal sign where there's the is. So is 30 equals 30. What's my keyword? Product. What does product mean? Multiplication. It's the answer to a multiplication problem. So I'm multiplying. What am I multiplying? G and 5. So how can I write that?
G times 5 equals 30.
G times 5 equals 30. Now what we've been learning since we've been started algebra, that there's another way that we can write this and not use a multiplication sign. You would write it as 5G equals 30. You're most likely going to see it in that form. Okay, because when a coefficient is touching a variable, multiplication is happening between the two. Alright, get your equals highlighter. Number 3 says a number k increased by 10 is the same as 24. Is the same as. So that's our equal part. Our problem part. Number k increased by 10. Alright. I'm going to decode it. I'm going to start with my equal sign. Equals 24. Well, what equals 24?
K plus 2.
Alright, what's our key word? Increase by. And what are we increasing it by? K and 10. It goes in the exact order that it's written because there's no flip words, right? So my answer is K plus 10 equals 24. Tomorrow, or not tomorrow, but on Wednesday, we're going to work on solving these. Because they have an equal sign, we can now solve them.
That means K equals 14.
Yeah, K does equal 14. Good job. Alright. Highlighter. Equal sign. Is. And then problem highlighter. What's the problem? The quotient of number Q and 4. What's our key word here? Quotient. And what does quotient mean? Division. I saw a lot of us do that as multiplication. That's one we got to learn is quotient means division. Okay? So I've got equals 12. And what equals 12? Q divided by 4 equals 12. Another way we've learned to write division is with what? Or as what? A fraction. Very good. So we could see it as Q divided by 4 equals 12. Because they want to trick you and make you think math is complicated, they're probably going to give you it in this form to try and test to see if you know that. Okay? Q is 48. Alright, number 5. Get out your equals highlighter. 2.5 is the same as the sum of a number W and a half.
Is the same as.
Is the same as. What's the problem part here? The sum of a number W and half. So I've got equals, and I got 2.5. What's our key word? Sum, and sum means to add. What are we adding?
W plus a half and
W plus a half. Now, here's the question, because the equal sign's up here at the front. Does it matter where the equal sign goes? No. Can it be at the front or the back? Are we going to freak out if we see an equal sign at the front? No, we're not. Okay? It means the same thing. Alright? How do we feel so far? Good? Pretty decent? Alright, flip it over to the back. We can get some more practice in here. Just very back. It says 8.1, notes continue. So we got some practice going on here. Alright? I'm going to do a few with you, and then I want you to try the rest on your own. Okay? So, I still want you to use your highlighters. I still want you to decode it underneath for every single one, whether you know how to do it or not. Okay? Practice makes perfect. Or not practice makes better, at least. Alright, number 1 says 12 less than a number x is 19. Where's our equal word?
is.
Okay. Alright, what's the problem part?
12 less than a number x.
12 less than a number x.
It's a swap.
Alright, so we're going to equals 19. And I'm going to focus on the problem part. I've got 12 less, and then than means what?
Swap.
Swap a number x. So we've got to swap what?
12 and x.
Okay, 12 and x. So I will write this as
X minus 12.
equals, that would be my answer. Do you remember our swap words? If it has than or from, those are our swap words. Okay? Several of us forgot that, and I might make a note of that somewhere to remind myself that if it has than or from, those are swap words. Okay. Number 2 says 1/3 of a number W is 16. What's my equal word? Is. What's my problem?
1/3.
Alright. What's our key word here?
Of.
Of. What operation does of fall under? Multiplication. Alright, so we've got multiplication. Equals 16. What are we multiplying?
1/3 times W.
1/3 times W. How can we write it without the dot?
With the multiplication.
1/3 W equals 16. This is the most algebraic way to write it. Alright, number 3 says 117 is 32 more than a number M. What's my is word? What's my equal word? Is. My problem? 32 more than a number M. So I've got equals 117. What's my key words here? Alright, more means what operation? Add. Than is a swap word. Alright, so our answer would be 117 equals M plus 32. Alright, number 4. A number q divided by 5 is 8. Our equal word. And then the problem. Another q divided by 5. What's our key word here? It's pretty clear. Divided, right? So q divided by 5. What's another way we could write this?
Q fraction 5.
Q over 5 equals 8. Alright, I want you to do through number 12. So 5 through 12. And we're going to check them at 10 o'clock. We got 8 minutes.
Okay.
It shouldn't take you that long to do it, but still want you to decode it and everything.